In lesson 4, we're going to look at how to graph quadratic equations in standard form and in vertex form. And remember, our whole goal is going to be trying to graph polynomials in general, so higher ordered polynomials. But before we do that, we're going to look more specifically into quadratics and graphing them. So a couple different things to point out here. All equations of the form y equals ax squared plus bx plus c are quadratic equations, and they have parabolas. So remember, parabolas are your U shapes. So opening up or opening down. If the parabola crosses the y-axis, that would be our y-intercept. If the parabola crosses the x-axis, those x values are our zeros or x-intercepts. The vertex is either going to be the highest or the lowest point, and that's going to be something that we're going to focus on when we graph parabolas, because the vertex is really what makes a parabola symmetric. It's basically what you could fold. So if you imagine drawing a line through the vertex, it's what you can fold along so that your parabola is symmetric. So the vertex is the turning point. It's where that symmetry really occurs. So we're going to really focus on that when we do quadratics, but we won't really focus on it when we look at sketching polynomials. In order to find the vertex, there's a couple ways that you can do that. The vertex is always halfway between any two zeros, and you can also find the vertex by using this formula. So you can use this formula, x equals negative b over 2a, or use the fact that the vertex is halfway between the zeros. I should say between the x value of the zeros. So the point won't actually be halfway between the two zeros, but the x value. Halfway between the zeros. I'm just going to write x value here. And you'll see what I mean by that when we do an example. You can also convert to vertex form. So that's going to be something that we're going to look at. So standard form of a parabola is y equals ax squared plus bx plus c, which is the common form. Vertex form, and I'll show you how to convert to vertex form, is y equals a times x minus h squared plus k, where h and k is the vertex. So that's another way to get the vertex. So we talked about basically 3 ways you can do it. You can use this rule. You can use the fact that the x value of the vertex is halfway between the zeros. You could also use converting the equation into vertex form and then just pull out the values. And we're going to look at all of those things. So this first example, we're going to run through and we're going to look at how do I graph this equation by hand. So we're not using a graphing calculator, everything by hand. So of course you could do it the traditional route where you use the axis of symmetry formula, x equals negative b over 2a, figure out what point lies in the middle of this graph, and then basically just plot some points. So basically choose some x values, plug them into the equation, get their corresponding y values. But to help prepare you for the next lesson, I'm going to graph this using the x-intercepts, using the y-intercept, using the leading coefficient test, some of those things that you have to be able to do in the next lesson. So the leading coefficient test, remember we talked about in the first lesson, and what that does is by looking at the leading coefficient and the degree of the polynomial, it allows us to determine the end behavior. So the leading coefficient is -1, the degree is 2, so since it's an even degree and it's a negative leading coefficient, I know that my ends of my parabola both have to be going down. So this really just tells me that both ends of my parabola are going down, my graph opens down. So that's important. The next thing that's going to be important is using those X-intercepts, because we know that our graph has to go down, but we don't know what's happening in here, where it's intersecting. So we're going to find those zeros. So we're going to take our equation and we're going to set it equal to 0 and we're going to solve it. So I need to get a 1 out in front here so that I can factor this. So I'm dividing everything by 1, or essentially just flipping the signs. And then I'm going to be able to factor this. We're going to have opposite signs, add to 2, multiply to -3. So we're going to have +3, -1. Split this and get our zeros. So we have x equals -3 and x equals 1. It's our two zeros. So we can go ahead and actually plot those. So right now I know that my parabola has to pass through 3 and it has to pass through 1, and both ends are going to be going down. So this is like the general shape. But the next part is, well, how high do I go? How do I know where to stop? Should I stop here or should I stop way up here? So that's why the vertex is going to be really important here for quadratics. So the vertex, like I said, always has to occur halfway between these points. So the distance between -3 and 1 is 4. So that means the vertex is going to occur at x equals 1, or x equals -1. So the vertex is going to occur at -1. So it occurs at x equals -1, but I have to find the y value. So to find the y value, you're going to take -1, you're going to go back up to your equation, and you're going to plug it in. And remember, when we plug into equations, we plug in using parentheses. So I plug in, and then I evaluate that. So we get 4. So that tells me my vertex is -1, 4. Now, if you use that -b over 2a formula, you would have gotten -1. But honestly, I think it's just much easier to look at the graph, find those zeros, count the distance, and go halfway over. So the vertex is halfway between the x values of the zeros. So the vertex point will not be here. It'll just mean that the distance, the x value, is halfway between these. So the vertex is actually at -1, 4. So let's go ahead and plot that. So -1 up 4. So this was, vertex was at x equals -1, not at that point. And then the last thing that we need to do is we need to figure out that y-intercept, because right now you could get a pretty good picture, a pretty good graph, because I know how high up to go. But to be even more accurate, you might as well plot the y-intercept. It's easy to plot because the y-intercept is just the constant at the end. So the y-intercept is just y equals 3. So it's just the constant. So that means I can go up to my graph, I can plot that point, and now I can connect all the way up to the vertex down through. And then we should label, and that's it. So remember, if you wanted to be more accurate, you can always take more points and plug in. So I could take -2 and I could plug it in to my equation and get another point. You know, though, that because parabolas are symmetric, that this distance, so once you know the vertex, so it's at x equals -1, every other point has to be symmetric. So since I went 1 unit to the right to get to 3, I would go 1 unit to the left to get to the next point. Let's say I figured out another point. I just know that I can plot points in both directions. So these points are all symmetric around this vertex here, or around the axis of symmetry, x equals -1. So let's do one more and we'll convert it into vertex form so you can see what that looks like. So the first thing I'm going to do is I'm going to take this equation and I'm going to convert this one into vertex form, just so that you can kind of see how to do that and see how you can get the vertex another way. But before I do that, I'm going to run through and do what we just did. And remember the process. We do the leading coefficient test. And in this case, I have a degree 2, so it's even. It's positive, so that means my parabola is going to open up. I know my x-intercepts can be found by setting this equal to 0. So x squared minus 6x plus 5 equals 0. Factor this one. And remember, if these aren't factorable, that just means that you can use completing the square quadratic formula. If it's factorable, then factor it. Makes it easier. So for this one, we are going to have the same sign, and they both have to be negative since we're adding to a negative. So 5 and 1, negative 5, negative 1. So x minus 5 equals 0, x minus 1 equals 0. So we get x equals 5, x equals 1. So you can go ahead and plot those. And remember, I know my parabola is going to be looking like this, but I don't know that vertex. So the vertex, you could do what we just did and say, okay, well, the distance between these is 1, 2, 3, 4. The vertex would have to be at x equals 3. And then plug in 3 to figure out the y value. So you can absolutely do what we just did. But I want to show you finding the vertex using vertex form. So we're going to go ahead and we're going to convert the equation to vertex form. And remember what I said, vertex form is y equals a times x minus h squared plus k, where the vertex is h comma k. It's always opposite signs for the h, but the k you keep the sign. So what I'm going to do is I'm going to take my equation. So y equals x squared. So I'm just copying that down, minus 6x plus 5. And we're basically going to treat it the same way. When you complete the square, because that's what we're trying to do, we're trying to get a perfect square right here, you always bring the number over. So I'm actually going to bring the number over with the y. Normally you'd have a 0. But since you have a y, you're just going to keep it. So it's going to be y minus 5 equals x squared minus 6x, and the 5's gone. So now what you're going to have to do is you're going to have to find a number to complete the square. You're going to have to find something that you can add to both sides. So you're going to split these two things up, x and x, split this up evenly, so minus 3, or you're taking half of it. And then what you do is you're squaring that number that you just took half of, so, or negative 3 times negative 3 gives me positive 9. So that is the number that you're going to add to both sides. So here on this side you get y plus 4, negative 5 plus 9 gives me 4, equals, over here, this whole thing is just your side lengths. X minus 3 times x minus 3 gives me this. So x minus 3 squared. And then normally at this stage you would square root both sides, but remember I'm trying to get it into this form where it's y equals the stuff squared plus k. So I'm just going to bring the 4 over, and now I have my parabola in vertex form. So the vertex is going to be 3, because it's always opposite sign, negative 4. Keep the sign. So that's just another way of finding the vertex. Now you might be thinking, well, why wouldn't I just count and then plug in? You can still do that. I just wanted to show you an alternative way. So the vertex is 3, negative 4. And then the only other thing that we should plot is the y-intercept. So the y-intercept, make sure the y-intercept, you do not use negative 4. Negative 4 is not the y-intercept because you'd have to multiply all this stuff out first and combine like terms, not just take the number at the end. The only time you can take the constant is if it's in standard form, which in this case, this one's in standard form. So the y-intercept is that positive 5. So the y-intercept is at 5. So I'm going to go up to 5. I'm going to go ahead and connect these. And my graph would keep going here. And remember that there would be another point that's the same distance away from x equals 3. So it's 1, 2, 3, 1, 2, 3 approximately. Because remember, you have to keep that symmetry. Now, another way too, if you converted to vertex form right from the beginning, you could have used this format to solve for the zeros. If I take this and set it equal to 0, it's easy to solve as well. So if you didn't want to factor, you could take this, set it equal to 0, and then solve from there. So that's another strategy to use. But that's really the big ideas. The only other thing I want to look at with you is actually looking at a word problem or an application problem. So I'm going to label this, and then let's look at one last thing. So on the next page, we have an example. First thing you need to do is just add a negative sign in here. So since this is demonstrating a projectile motion, you have to have a negative out in front there. So basically the scenario here is we have a rocket that's launched from a cliff. So let's just kind of draw a picture. So we have some cliff, and we have this rocket that's launched from the cliff. So we have a rocket that's getting launched, so it's going to go up, and then eventually it's going to come back down. So this picture here, we can use a quadratic equation to model that, which is this equation here. And we're going to actually be a little more accurate and find the specific points so that we can answer some questions. So the heights in feet and the time is in seconds. We want to first sketch a more accurate picture, and then we're going to answer these questions. So when we sketch the picture, we know automatically by the leading coefficient test that my parabola is going to be going down, which it always should be. So that's why I had to add this negative in here. That was just a typo. Because my parabola has to open down if it's actually modeling an object being thrown. So the next thing then is to figure out the zeros or the x-intercepts. So the x-intercepts, we set our equation. So negative 16t squared plus 80t plus 384 equals 0. And then if you can, you want to get rid of this negative 16, which in this case, I can divide everything by negative 16, so it works out nice. So I'm left with t squared minus 5t minus 24 equals 0. And then we can factor this. If, again, it doesn't factor, which sometimes happens with these application problems, all you got to do is do quadratic formula, completing the square, get decimals, and just approximate from there. So we have t. We're going to have opposite signs. So we're going to have minus 8 and plus 3. So we get t equals negative 3 when we set these equal to 0, and t equals 8. Now, the thing with these, since this is a word problem and t represents seconds, I'm going to just look at the negative 3, but I'm not going to actually plot it, because if you look, I'm actually starting at my initial, like this is like my y-axis. My initial height is actually the point I'm starting at. I'm not actually starting at my x-axis. So when we graph this parabola, it won't actually be symmetric because we want it to start at the y-axis, we want it to come up to the vertex, and then it's going to hit at the x-axis. So I don't really care about this section of my graph, which is that other x-intercept, because it's negative. But I'm going to still, when I look at the graph here, I'm going to still just draw it in 1, 2, 3, like this. And then I'm going to count over the 8. So 2, 4, 6, 8. Only because I like to visually see, okay, well, where's my vertex going to be? So if you look, there's 11 units between these. So that means I'd have to go over 5.5 to get to the vertex, or to get to the axis of symmetry. So 1, 2, 3, 4, 5.5 is where I know that my vertex is going to have to be. So let's work on now finding the vertex. So it's going to be at x equals, well, 5.5 over, but that's really x equals 1, 2.5. So we're going to plug in. I should call this t though, because remember it's time. So I'm going to plug in to my equation. .5. So when you plug all that in, you get 484. So that means the vertex is actually going to be 2.5 comma 484. So go ahead and plot that. And if you look, I think if we go up by 50, that should be a good scale here. So let's make every 2 boxes 100, because we got to fit 484. So remember, this is actually going to be height, and this is time down here in seconds. So this is S, this is height, or actually I should call this time and this height. So what we're going to do then, plot that vertex, so 2.5 up 484. So again, you're just kind of approximating this. And then the only other thing we need to worry about is that Y-intercept, which is easy to find because it's just that number at the end. So 384. So 0 up to 384. And again, we had our X-intercepts. I'm not plotting that -3 because I really want my, remember this rocket's going to start at the top of this cliff, which is the Y-intercept. It's going to go up to the maximum height, and then it's going to come down, and it's going to stop at the X-intercept. So this would actually be the motion, or the graph that represents the motion of this rocket. So the last thing here is just the follow-up questions. So when will the projectile hit the ground? Well, it'll hit the ground after 8 seconds. It'll hit the ground right here, which is after 8 seconds. So after 8 seconds. And this will always be basically the positive X-intercept. The time when the height is 0 is going to be the X-intercept. We don't want the negative one, we only want the positive one. When will the rocket hit its maximum height? Well, it'll be at this point. This is the maximum height, which is at 2.5 seconds, or after 2.5 seconds. So actually it'll be at 2.5 seconds. And again, this is going to be the X value of the vertex. What is the maximum height is what's the Y value now. So how high is it? Well, it's 484 feet in the air. So this is always going to be the Y value of the vertex. And then the last thing, at what height was the rocket launched? So what's the initial height? This is always going to be the Y-intercept. So for this particular problem, the initial height was right here. That's how high the cliff was. That's where it was starting. And 384 feet. And it'll always be the Y-intercept. So it'll always be this initial height at the end, or the value at the end.